Hello and welcome to the BMC Learning Series. Today we'll be reviewing the basic infrastructure of MainView Batch Optimizer, or MVBO. The MainView Batch Optimizer infrastructure consists of 4 started tasks. These tasks are normally started during the IPL process of an LPAR and are intended to remain up and running until the next IPL cycle. The started task default names are BMC Primary Subsystem, or BMCP, the BMC Consolidated Subsystem, or BCSS, the BMC Pipes Subsystem, or MBOP, and the Extended Job Execution Subsystem, or MBOX. Now let's take a look at each of these started tasks in detail. It all begins with the BMC Primary Subsystem. The BMCP is shared among several BMC products and is not unique to MainView Batch Optimizer. The BMCP is a relatively benign address space that paves the way for an additional address space, the BCSS. You can have one and only one instance of a BCMP running in each LPAR. During the IPL process, start the BMCP as the first started task for BMC products. Leave it up even though it will do little work after it's been initialized. If you already have a copy of BMCP up and running on your system, you have another product that is also using the BMC-related infrastructure. It's important to coordinate product maintenance activities to ensure that you have maintenance level compatibility between the products that share this started task. The JCL for the BMCP, as well as all of the MVBO-related started tasks, typically resides in your standard proclib for started tasks. BCSS is short for BMC Consolidated Subsystem. Like the BMCP, the BCSS infrastructure is shared among several BMC products. The BCSS requires that the BMCP is up and running before it will initialize. Unlike the BMCP, which allows only a single instance to be running on each LPAR, you can have multiple BCSS started tasks up and running on an LPAR. Even though the BCSS infrastructure is shared between products, the specific BCSS started tasks are unique to each product. The default BCSS subsystem for MainView Batch Optimizer is MBOS. The BCSS provides important administrative services. 2 of the most visible are the management of the history dataset, or regiset, and secondly, the BSL-Plex DD points to the Plex PDS that contains the rules that dictate how the product will function. Here's an example of the execution JCL for the BCSS. Like the BMCP JCL, it typically exists as a member in your started task proclib. The BSL-Plex dataset is the same dataset you'll manipulate in the ISPF panels. It contains all of the members that control the function of the product. The regiset is a repository that contains much of the activity-related history used by the product to optimize jobs. You'll probably have separate datasets for a test version and a production version of the product. The Job Optimizer Pipes Subsystem is used to perform data transfer between job steps or separate jobs. The default subsystem ID is MBOP. When you issue commands to the MainView Batch Optimizer Job Optimizer Pipes subsystem, the commands must be preceded with a modify F, followed by the subsystem ID. Now here's an example of the MBOP started task JCL. Notice that the BSL-Plex DD is the same for both the MBOS as well as the MBOP tasks. The MBOXJS, or Extended Job Execution Subsystem, is started when the MainView Batch Optimizer Job Optimizer component is enabled. The default subsystem ID is MBOX. When the Job Optimizer component is executing, batch job steps execute in either serial or parallel fashion. The serialized steps run on the JS initiator, while the step splits run on the XJS initiators. Start only one MBOX started task for each LPAR. Additional XJS initiators will be spawned as needed for step splitting. Here's an example of the MBOX started task JCL. The MBOX started task is started along with the rest of the MVBO infrastructure. One thing that might surprise you is that the started task will go away once it spawns the first XJS initiator. This is okay and to be expected. Now let's see what a job looks like when steps are split and running on an XJS initiator. This is what a job looks like on an SDSF when it's split. In this example, the job is being split into 6 parallel steps. The job name is BDL split. We rename job steps to fool JES. Only one job with a certain name can run at a time. Brackets mean that this step is running on an XJS initiator. The first step is executing in JES2 initiator in class A. The other steps are executing on a MainView batch optimizer XJS initiator with the bracket symbol next to the batch job executing. The bottom display shows what you see when you scroll to the right. Notice that each split step is assigned to a unique ASID. When the MainView batch optimizer started tasks are initialized and the job optimizer component is enabled, one XJS initiator is started. This initiator will remain active until after the first batch job has been dynamically split. After this, as the workload requiring XJS initiator services reduces or completes, the XJS initiators are dynamically drained until needed. No XJS initiators will remain active. The XJS initiators are managed by the MainView Batch Optimizer subsystem. Remember, only job steps that are dynamically split by the job optimizer component will use the XJS initiators. That concludes the review of MVBO's architecture. For more videos on MainView and other BMC solutions, please visit our BMC mainframe YouTube channel at youtube.com/user/BMC software mainframe/featured. That's it for this session. Thank you and see you next time.